Hey, this is Mr. Barr, and this is graphing using slope-intercept equation. Make sure you watch to the end of the video. Our goal, I can use line equations to solve real-life problems. Why? Line equations will help me understand the world around me and make predictions. Today you're going to learn one of the most important equations in math called the slope-intercept equation. You will be using this equation in every math class you take for the next 4 years. Learning it well today will make your life easier for years to come. All right. So I've got this table of value, and I can fill it in using the function. This is something we did, I think, 2 lessons ago. So if I plug in a -1, 2 times -1 is -5. Excuse me, 2 times -1 is -2, minus 3 is -5. Let's plug in a 0. 2 times 0 is 0, minus 3 is -3. Let's plug in a 1. 2 times 1 is 1, minus 3 is -2. And we have these 3 points. We have a point at -1, -5. We have a point at 0, -3, and a point at 1, -2, 1, 1, -1. And using those points, I can connect them and I get a line. All right? The thing is, I'm going to show you that there's a way to do this without the table, without drawing a table. Check this out. See that -3? Actually, check it out when I can actually draw on my screen. See this -3? Come on, Bar. Get your pen right. You see this -3 right there? You see that -3? That -3 is right here. And you see this? This is actually the slope. It says go up 2 and over 1, up 2 over 1, up 2 over 1, up 2 over... It draws the line for me. This equation draws the line for me without the table. So how does it all work? What is the magic? Once again, you see this guy right here? See that -1 or -3? It's that point right there. See this 2 over 1? It's the slope of the line, 2 over 1. Everything you need is right here, right there. Everything. All right, so let's get into our notes here. And our title is Graphing Using the Slope-Intercept Equation. Graphing using the slope-intercept equation. And what specifically is the slope-intercept equation? It is right here. It is y equals mx plus b, where m is the slope and b is the y-intercept. Slope is rise over run. If we were doing this lesson in class, we would now sing a song. Actually, we'd probably sing 2 songs. Let's sing 2 songs. I'll do them both. Here we go. One of them is the y equals mx plus b song, and it goes like this. You grab a mug from the shelf, and you bring it down like this, and we sing together. We go, y equals mx plus b, 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 and then you go cheers with a neighbor. And then you take your mug and you crash it onto the floor. For some reason, this seems like a pirate song. I'm not sure why. The other song we like to sing is the one for slope. What is the definition of slope? Rise over run, Rise over run, the slope is defined. Rise over run, dum 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 dum. Rise over run, the slope is defined. Rise over run. And if we were doing this in class, we might do this like burpees or CrossFit style, right? CrossFit style? CrossFit style. It's like a, what is it? Rise over run. Rise over run, the slope is defined. Rise over run, I'm done. 3 burpees is enough for me to right now, especially since I have to keep teaching. All right, so we did the y equals mx with b, and we did rise over run. Let's go back to those notes. So when I'm looking at an equation with the numbers in it, like this, I know this is my slope, and that's my y-intercept. And you can't see what I'm writing. Whew. I need a drink of water. And if I have those two things, I can graph the line. Or better yet, maybe I don't want to graph the line. That is okay, because here is Liam the leprechaun, and he is a line graphing machine. But the thing with Liam the leprechaun is he only knows how to run and rise. This is all he knows how to do all day long. Actually, boom. What am I, right there? That'll work, okay. This is all Liam knows how to do. That's it. That's all he knows how to do. But if you give him the right information, he will graph the line for you. Uh-oh. You didn't see that. You didn't see that, did you? Uh-oh, I gotta do it again. Sorry, man, I was off the camera. There it is. Okay, let's try it again. Here. This is all Liam knows how to do. Let's see. I don't even know which way is positive in this world. Okay, but here, this is what he knows how to do. He knows how to rise and fall and run. Rise and fall and run. Rise and fall and run. That's Liam the leprechaun. And that is all he knows how to do. Let's see. So the M stands for Liam's move, and the B stands for his B. And what I mean by that is it's where Liam wants to be when he first jumps onto the graph. So Liam's going to jump onto the graph, and then he's going to start moving. So Liam jumps onto the graph, and then he starts running around, like that. Okay. So let's see how this works. So looking at this equation right here, right here, Liam wants to start his life at 1. There he is. Hello. And then he wants to go up to right 3. 1, 2, 1, 2, 3. And now he's right here. And he wants to do it again. Up 2 over 3. But now he sees the pattern and he looks backwards and he says, oh, you know what? I bet I could go this way also. Down 2, 1, 2, 3. Down to 1, 2, 3. And once he's dropped, actually, I say that he's like dropping little coins. He drops coins from his pot of gold. And then once we have all those points, we can draw the line. try another one. Oh, there it is. So I look at this and I ask myself, where does Liam want to be? Liam wants to be at 3. Hey, that rhymes. Be at 3. Does he want to be right here? No. Right here? No. Right here? He wants to be at the 3 on the y-axis. How does he want to move? Well, this means he wants to go down 4, and he always goes to the right. So he'll go right 5. Down 4, 1, 2, 3, 4, 1, 2, 3, 4, 5. Down 4, 1, 2, 3, 4, right 5. 1, 2, 3, 4, 5. Always right. And then I connect the dots and I have a line. Let's try another one. Where does Liam want to be? Liam wants to be at -4. How does Liam want to move? Well, I know that slope is rise over run, so he wants to rise up 2, and he wants to run 1. Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. I connect the dots and I get a line. Let's do another one. Where does Liam want to be? Liam wants to be right here at 2, so he goes up to 2. He always starts on the y-axis. How does he want to move? Well, what number's in front of this? Well, there's a 1 in front of this. And what's that over? It's over a 1. He wants to go up 1, right 1. Up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. And he can continue the pattern in the opposite direction also. Ooh, okay. Y equals x, how about this? Plus 0. And what's in front of this? A 1 over 1. He starts at 0, he goes up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1, and he continues it in the opposite direction also. We are not done with our notes yet. Keep those notes available. And our final one, where does he start? He starts at 0, and he goes down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. All right, back to those notes for a moment. So you've seen how Liam kind of does his job. So we'll take some quick notes about Liam and how he likes to do his work. Here's the y-axis. So 1, let's go with step 1. Put Liam on the y-axis at the y-intercept. To rise or fall if it's negative. Put Liam on the y-axis. Put Liam on y-axis at the y-intercept. Rise or fall if it's negative. And then 3, run to the right. So if I had y equals 1/2 x plus 2, put Liam on the y-axis, rise or fall, go up 1, run to the right, 1, 2, there's my line. Put Liam on the y-axis, rise or fall if negative, run to the right. And that's it for today. Thanks for watching.